All right, angles outside a circle is another relatively quick little lesson. Basically, we're just going to deal with a single theorem, and that is when we're dealing with an angle that arises outside of a circle or is originated outside of a circle, there's really three different possibilities. Either it starts out here, like we have in our first one here at point D, and then both sides of the angle pass through the circle, like chords, or we have one like in the middle where it starts here at L. One line is actually tangent to the circle, just touching the circle here at point M, and then the other line is also tangent to the circle, just touching it at point N. Or our third option where we start here at Q, where we have one line that's tangent here at point R, and the other line that passes through the circle like a chord. What's nice is that no matter which of these options we end up running into, the method for calculating the angle is the same. And that is that we take the two arcs, the two arcs that are described by the angle, and we find the difference between them, and then we take half of that measure, and that's the measure of our arc, of our angle. So if, for instance, we had, say, this arc here represented 110 degrees, and then this arc out here represented 250 degrees, then we would add those together, 360, which of course makes sense since these are just tangent points, right? Then we would divide 360 by 2 to get 180. Oops, I'm sorry. We would subtract them, not add them. Well, I was thinking that doesn't work. 180 degrees is too big. We subtract the two of them. We take 250 minus 110. That seems a little more reasonable. And that gives us 140. And that 140 divided by 2 is 70, so that our measure of our angle in here at L would be 70 degrees. Yeah? So we just find the difference between the two angles and then divide the difference by 2 to get the measure of the degree of the angle. So it's pretty straightforward. Let's do a few examples of these with our example questions.